We are going to start now chapter 6 class 11th mathematics linear inequations. This is lecture 1. We start this chapter with the definition of the linear equation in one variable. So we are saying that any equation of these forms, it is of the form ax plus b is less than c, ax plus b is less than equal to c, ax plus b is greater than c, and ax plus b is greater than equal to c, where a, b, c are the real numbers. These are the inequalities in x in one variable. When we are saying inequality, it means when we are talking about the linear equation, we are saying ax plus b is equal to c. Now in place of this equality, we can have less than sign, greater than sign, greater than equal to sign, or less than equal to sign. Then these are the linear inequalities in one variable. Next is some examples are given over here. If we are saying 2x plus 3 is less than 7, 3x minus 5 is less than equal to 10, this 3x plus 2 is greater than 8, and 4x minus 3 is greater than equal to 9. So these are all linear inequalities in one variable. One variable means we are talking about the variable over here, it is x. Next definition we have is the replacement set or the domain of the variable and the solution set. So domain of the variable or the replacement set, we are saying, suppose I am talking about 2x plus 3 is less than 7, and I am saying that x can take the value from the set of say integers or say rational numbers. We are saying x belongs to q. So the replacement set over here, that is just the domain we are saying, so it is q, and the solution set is the set of all those elements. We are saying all those rational number, because q is the replacement set, which satisfy 2x plus 3 is less than 7. This gives us this is the definition for the solution set. It is those elements of the replacement set which satisfy this inequality, that is called the solution set. Next is write down the solution set of the inequation x is less than 6. When we have the replacement set as natural number, we are saying we are talking about x belongs to n such that x is less than 6. So the answer we have, it is 1, 2, 3, 4 and 5. Next we are saying when x is a whole number, the replacement set we have, it is whole number, domain we have, it is whole number. So we are writing it is x is less than 6. So the answer we will have, it is 0, 1, 2, 3, 4 and 5. And next we have it is x belongs to integers and x is less than 6. So we are saying all integers less than 6. So it is 0, 1, 2, 3, 4, 5, and it is minus 1, minus 2 and so on. So these are the solutions that we have in this case. So the final solution set, it depends upon the replacement set. It depends upon the domain of that given function, you can say, or inequality we are saying. Next is the rules for solving an inequation. So these are some particular rules that we can follow. First is adding the same number or expression to each side of an equation, it does not change the inequality. So we are saying that suppose we are having the inequality that x is less than 6 and we add some number, we are adding 3 on this side, we are adding 3 on this side. Our inequation will become x plus 3 is less than 9. So we are saying that this inequality, it is not changed, the less than sign will remain less than sign. Similarly, we are saying if we are subtracting the same number or expression on each side of the equation, it does not change the inequality. So if we are talking about this equation, we can write that x plus 3 say minus 9 is less than 9 minus 9. We are subtracting 9 on both sides. So again this inequality, this sign of inequality, we are saying it is less than sign, it will remain same. Next is on multiplying or dividing each side of the inequation by the same positive number does not change the inequality. So if I am saying that we have 2x is less than 6 and I am dividing both sides of this equation with 2. So, this will give us x is less than 3. The sign of inequality is not changed. And last case we have multiplying or dividing each side of equation by a negative number reverses the inequality. So, if we have the inequality in the form, suppose I am saying that minus 3 is greater than x and I am multiplying both sides of this equation with minus 1, then this greater than sign will become less than sign, this will reverse. So, you will get that 3 is less than minus x. Similarly, suppose I have minus 2x is less than 6 and I am dividing both sides of this equation with minus 2, then this sign will be reversed, this will become greater than sign. The answer we get is x is greater than minus 3. So, this thing is important, that if we are multiplying or dividing an inequality with a number having the negative sign, then this sign of inequality, the greater than will become less than will become greater than. So, this is important rule. In rest all these three cases the sign of inequality will not change, but in this last case the sign of inequality will change. Next we have is transposition. So, we are saying using rule 1 and 2 we can drop any term from one side of an inequation and put it on the other side with the opposite sign. So, we are talking about ax plus b, say it is less than c, and from our first and second rule we are saying that we can write it is ax plus b minus c is less than c minus c. So, this gives us ax plus b minus c is less than 0. So, this thing we can look over here, in place of saying that we are subtracting c on both sides, we are naming this that we have done the transposition of c, that we have shifted this c from this side of inequality to other side and the sign of inequality will remain unchanged. This is called the transposition. So, this thing is explained over here, that if we had x plus 3 is less than 2, we can write it is x is less than 2 minus 3 implies us x is less than minus 1. Similarly, we have 2x minus 3 is greater than equal to 6, we can write it is 2x is greater than equal to 6 plus 3. This gives us 2x is greater than equal to 9. So, this gives us x is greater than equal to 9 by 2, because 2 is a positive number. So, when we are dividing by 2 on both sides, the equality, this inequality sign, this will remain same. So, we are getting x is greater than equal to 9 by 2. Now, based upon this, we have certain problems. So, first is 5x is less than 24 and these are the replacement sets given to us. First is x belongs to n and second is x belongs to z, and we have to represent the solution on the number line. So, if we look at this value, we are dividing both sides with 5, we will get x is less than 5, 5 is a positive number. So, sign of inequality will not change, we are saying we are talking about x is less than 5. So, in this first case, we will have x belongs to n and x is less than 5. So, the solution set we have is 1, 2, 3 and 4. In this second case, we are saying x belongs to z and we have x is less than 5. So, the solution set we have is 0, 1, 2, 3, 4, then it is minus 1, minus 2 and so on. So, when we are representing these numbers on the number line, the representation of these numbers, we are saying these numbers, we have drawn the number line over here. This is 0, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3. We are talking about the number 1, 2, 3, 4. So, these are the numbers, we represent them with the dark dots over here. So, these are the 4 numbers we have over here. Similarly, in the second case, we are representing the solution set. So, we are saying this is 0, minus 1, minus 2, 1, 2, 3, 4, 5. Now, the solutions we have, it is 4, 3, 2, 1, 0, minus 1, minus 2 and so on. so on we represent over here. So this is the representation of these numbers on the number line, and this is the representation of the number 1, 2, 3, 4 on the number line. Next is this inequality is given and the replacement sets are x belongs to n and x belongs to r. So in the first case we are talking over here, it is 12 plus, if we solve this value we will obtain it is 11 by 6, x is less than equal to 5 plus 3x. So this implies us that 72 plus 11x is less than equal to 30 plus 18x. What we have done, we have multiplied this whole, both sides of this equation with 6. We have multiplied both sides of equation with 6. It is a positive number. So this inequality will not change, sign of inequality will not change. So this implies us that 72 minus 30 is less than equal to 18 minus 11x. So this gives us the value of x we have. We are saying the value we have over here, it is 7x is greater than equal to 42. So this implies us that x is greater than equal to 6. Now look at this replacement set. We are saying x belongs to n. X is greater than equal to 6. So we are talking about the number 6. It is equal to sign over here. So 6 is included. 7, 8 and so on. In the second case, the replacement set we have, it is r. So we are saying it is x belongs to r and x is greater than equal to 6. And we know from the intervals, we know that this represents the interval 6, infinity. Now if we have to represent these numbers on the number line, we are saying suppose this is the number minus 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. We have numbers like this. So these are the numbers we are saying 6, 7, 8. We are talking about 6, then 7, then 8. These are 6, 7, 8 and so on. So these are the numbers represented over here in the number line. And when we are talking about the representation of this interval, we are saying this is 0, say 1, 2, 3, 4, 5, 6. This is minus 1. So we are talking about the interval we have over here, it is the elements we have over here, it is 6 to infinity. So basically we are saying that 6 is included over here, and after this all the numbers are included. So all these numbers are represented in this form. On the number line this is represented in this form, that it is the interval 6 to infinity, and the interval it is closed at 6. So this dot over here, it is the dark dot. If suppose we have the interval open interval 6, infinity, then we will represent like this. This is the number 6. We will represent it like this. The dot over here, that will be the empty dot we will have. Next is this inequation we have to solve. It is x plus 4 over x minus 2 is greater than 0. So to solve these kind of inequations, we look at a formula over here. We are saying that a, b is greater than 0. We have two real numbers a and b, and it is greater than 0. So this thing will imply us that the signs of a and b are same. So this implies us that a is greater than 0 and b is greater than 0. Either we have this case, or we have the case a is less than 0 and b is less than 0. Similarly, if we are talking about the case a, b is less than 0, it means that the signs a and b have opposite signs. So if a and b have opposite signs, so it means if a is greater than 0, then b is less than 0. If a is less than 0, then b is greater than 0. Similar is the case when we are talking about the condition. A by b. Clearly b will not be equal to 0 if we are talking about this number. So we will have, if this term is greater than 0, then the sign of both a and b should be same. If a by b is less than 0, then they should have opposite sign. Now in this case it is given that this term is greater than 0. So we will have x plus 4 is greater than 0 and x minus 2 is greater than 0, or we are saying, or we will have the case that x plus 4 is less than 0 and x minus 2 is less than 0. If we solve this part, we are saying this is representing x is greater than minus 4 and x is greater than 2. You look at this part, it is representing x is less than minus 4 and x is less than 2, and it is or in between these two. Now if we plot these numbers, we are talking about, we plot these numbers, look at the interval over here, we are saying this is 0, somewhere over here it is minus 4 and over here it is the point 2. We are saying x is greater than minus 4, minus 4 is not included, and we are saying that x is greater than minus 4. Second, we are saying x is greater than 2, this is not included, and we are talking about this region. So the common region we have, it is this, it means we are saying x is greater than 2, this is the common region over here, because it is and in between these two, so we are talking about the common region. Similarly, in this case we are saying this is the point 2, this is 0, this is minus 4, and we are talking about the regions x is less than minus 4, this portion, x is less than 2, this portion. The common region we have over here, it is this, that is x is less than minus 4, and it is or in between these two terms. If we are looking at these two terms, we are saying x is greater than 2 or x is less than minus 4. So if we plot these numbers on the number line, we obtain, this is the region we are representing over here, x is greater than 2, this portion we are saying this is corresponding to x is greater than 2, and this portion we are saying this is x is less than minus 4, and it is important to note over here that at minus 4 and this point 2, these are not included. So the solution set we have, it is minus 4 to minus infinity to minus 4, this is open interval over here, union 2 to infinity. So this is the solution set in this case. Next is solve x minus 3 over x plus 4 is less than 0. So again we have two cases over here. In the first case we are saying x minus 3 is less than 0 and x plus 4 is greater than 0. The sign over here, it is negative, it means both will have opposite signs. Second, we are saying x minus 3 is greater than 0 and x plus 4 is less than 0. So this equation will imply us that x is less than 3 and x is greater than minus 4. This will imply us x is greater than 3 and x is less than minus 4. If we plot this region, if we plot these values, we are saying this is 3 over here, minus 4 over here. So what these regions are representing, x is less than 3. We are saying this is x is less than 3 and the 3 is not included. Second, we are saying x is greater than minus 4 and minus 4 is not included. So the common region we have this portion, both minus 4 and 3 are not included. So we have minus 4 comma 3 open interval, and in this second case, if we plot the answers over here, we have this point, it is minus 4 and this point it is 3. So we are talking about x is greater than 3, x is greater than 3 and this point 3 is not included. And the second case we are saying that x is less than minus 4, at this point minus 4 is not included. So there is no common region between these two, so this set represents, it is the empty set. Now next we have, it is or in between these two, that either this thing will hold or this thing hold or both can hold. So we are saying that or means it is union of these two sets. So the final answer we obtain, it is minus 4 comma 3, and when we represent this portion on the number line, it is this portion of the number. This is minus 4 to 3 and minus 4 is not included and 3 is not included. Both these points, these are not included. Next we have is x minus 2 over x plus 5 is greater than 2. So this thing implies us that x minus 2 over x plus 5 minus 2 is greater than 2. Important thing to note over here is that we are not cross multiplying this term on this side. We are not taking this term on this side. The reason being that we do not know the value of x. We do not know the value of x. If suppose we have the value of x is minus 7, then this term x plus 5 will be minus 2, and if we multiply this term on this side, this inequality will be reversed. So this is the reason why we are not cross multiplying it over here. We are just solving it on this side. So we are saying that the equation we have, it is x minus 2 over x plus 5 is greater than 2. So we are subtracting 2 on both sides. So this side, this will become 0, and this side we get it is x minus 2 minus 2x minus 10 divided by x plus 5 is greater than 0. So this implies us that minus of x minus of 12 divided by x plus 5 is greater than 0. If we take minus sign common, we obtain it is minus of x plus 12 over x plus 5 is greater than 0. Now if we multiply both sides of this equation with minus 1, this sign will be reversed and it will become less than sign. We are multiplying it with minus 1. So the inequality will become x plus 12 over x plus 5 is less than 0. So we are having two cases. First is that the sign of x plus 12 if it is less than 0, and x plus 5 is greater than 0. It is less than 0 over here, so one will be positive, other will be negative. Next is x plus 12 is greater than 0 and x plus 5 is less than 0. In this case, we obtain it is x is less than minus 12 and x is greater than minus 5. In this second case, we have x is greater than minus 12 and x is less than minus 5. If we plot these on the number line, we have minus 5 minus 12. Over here we have it is minus 5 minus 12. So if we plot these on the number line, we have x is less than minus 12 and x is greater than minus 5. And these 2 points, these are not included. We are saying minus 5 and minus 12 are not included. It is and in between these two. It means we are interested in common region. There is no common region over here. And in this second case, we are saying x is greater than minus 12. We are talking about this portion. X is greater than minus 12. X is less than minus 5. We are talking about this portion. Both these points, these are not included. The answer we have it is minus 12 to minus 5. And we have or in between these two values. This or in between these two values. This thing can hold or this thing can hold. So the union of these two values, the final answer we obtain it is minus 12 to minus 5. So this is the solution set for this inequality. Next we have to solve 5 by x minus 2 is greater than 3. So in this case we are saying 5 over x minus 2 is greater than 3. So this implies us that 5 over x minus 2 minus 3 is greater than 0. So this implies us 5 minus 3x plus 6 over x minus 2 is greater than 0. So this implies us that minus 3x plus 11 over x minus 2 is greater than 0. We have two cases. In the first case, we are saying minus 3x plus 11 is greater than 0. X minus 2 is greater than 0. Minus 3x plus 11 is less than 0. X minus 2 is less than 0. So in this first case, we will obtain, we are talking about this value, we are getting it is minus 3x is greater than minus 11. 3x is less than 11. X is less than 11 by 3. In this second case, we are having and over here. X is greater than 2. Now coming to this part, it is minus 3x plus 11 is less than 2. So we get minus 3x is less than minus 9. X is greater than 3 because we are dividing it with minus 3. So this inequality, sign of inequality will change, and we have and x is less than 2. So in this case, clearly we have x is less than 2 and x is greater than 3. So the solution set in this case will be 5. In this case, we are saying that x is greater than 2 and x is less than 11 by 3. So the common region we will have it is 2 to 11 by 3. Common region we will have it is 2 to 11 by 3. So the final answer we obtain is that union of these two sets. So the final answer we have it is 2 to 11 by 3. It is open interval over here. Next we have to represent the solution set on the number line. So when we are representing this solution set on the number line, we are saying we have to represent 2 comma 11 by 3 on the number line. So this is the solution we have. It is 2 to 11 by 3, and both this 2 and 11 by 3, these are not included. Next is let a be a positive real number. Then we are talking about the properties of the modulus, and we are saying that mod of x is less than a. This thing means that minus a is less than x is less than a, and the solution set in this case means that x belongs to minus a to a. The definition of mod function we have, it is equal to x if x is greater than equal to 0, and it is minus x if x is less than 0. So if I am talking about that mod of x is less than a, and I try to plot these points on the number line, suppose I am talking about the number a we are talking about, say it is over here, this is the number a we are saying. We are interested in all those real values. We are saying x belongs to R, such that mod of x is less than a means that distance of x from 0 should be less than a. We are saying, suppose this is the point O we have, 0 we have, that all the points within a distance of a, we are saying on this right side, this is the point A. On the left side, we will have this is the point A. The distance of this point from the origin is A. Distance of this point from the origin is A. So we are saying the solution set we have, it is all points between minus A to A. They will satisfy that mod of x is less than A. That is their distance. All those points whose distance from the origin, it is less than A. Similarly, when we are saying mod of x is less than equal to a, the answer will be the closed interval minus a to a. Next case we are talking about, it is mod x is greater than a. When we are saying mod x is greater than a, it means we are talking about all those real numbers whose distance from 0 is greater than a. So if we look at this number line again, we are saying we are interested in all those real numbers whose distance is greater than a. So it means these all numbers, we are talking about this portion, all these numbers after a and all these numbers before minus a, they will have the distance from the 0 greater than a. So we are saying the solution set we have is that x is less than minus a or x is greater than a. This is the second case we are talking about. And when we have equality over here, we are saying that mod of x is greater than equal to a. This is implied and implied by x is less than equal to minus a or x is greater than equal to a. So these are some basic formulas when the modulus function is there. So the first problem based upon this is we are talking about mod of 4 minus x is less than 2. The formula we have is mod of x is less than 2. This implies us minus 2 is less than x is less than 2. in place of x now we are having 4 minus x. So this will implies us that minus 2 is less than 4 minus x is less than 2. If we subtract 4 from this, we are getting it is minus 4 minus 2 is less than minus 4 plus 4 minus x is less than minus 4 plus 2. So we get minus 6 is less than minus x is less than minus 2. If we multiply this whole inequality with minus 1, this will become 6, this sign will be reversed, this will become x, this sign will be reversed, we get it is 2. So the answer we are obtaining is that 2 is less than x is less than 6. So this gives us x belongs to the interval 2 comma 6. Obtain that x belongs to the interval 2 comma 6. Similarly, in this next case, we have mod of 3x minus 2 is less than equal to 1 by 2. So this implies us minus 1 by 2 is less than 3x minus 2 is less than 1 by 2. This implies us 2 minus 1 by 2, we are adding 2 to this equation, is less than equal to 3x is less than equal to 2 plus 1 by 2. This implies us this value when we are saying 2 minus 1 by 2, that will be 3 by 2 is less than equal to 3x is less than equal to 5 by 2. So the answer we obtain is that 1 by 2, if we divide this whole equation by 3, it is a positive number, the signs will not be changed, is less than equal to x is less than equal to 5 by 6. So we are saying x belongs to R such that this, so this represents an interval 1 by 2 to 5 by 6 and it is a closed interval. Next is solve mod of x plus 1 is greater than 4. So we have seen the formula that mod of x is greater than a. This implies us that x is less than minus a or x is greater than a. So this implies us that x plus 1 is greater than 4 or x plus 1 is less than minus 4. This first part implies us that x is greater than 3 and the second part implies us that x is less than minus 5 and it is or in between these two. When we are saying it is or in between these two means we are talking about the union of both these. So if we try to represent them on the number line, this is 3 over here, this is minus 5 over here. We are saying x is greater than 3, x is less than minus 5 and both these points, these are not included. So the answer we obtain is minus infinity to minus 5 union 3 comma infinity. So this is the solution set in this case. Next is mod of 3 minus 4x is greater than equal to 9. So again we are having two cases, that 3 minus 4x is less than equal to minus 9. 3 minus 4x is greater than equal to minus 9 plus 9 and it is or in between these two. Now the first one will give us that minus 4x is less than equal to minus 12. Second will give us minus 4x is greater than equal to 6. This implies us if we divide it with minus 4, this will give us x is greater than equal to, this sign is reversed over here, we are dividing it with minus 4, 3. When we divide it with minus 4, we get x is less than equal to minus 3 by 2. Now if we plot these on the number line, we are having this number 3 over here and minus 3 by 2 will be over here. We are saying we are interested in x is greater than equal to 3 and x is less than equal to minus 3 and both these points, these are included. So the answer we obtain is minus infinity to minus 3 by 2 union 3 to infinity and the interval it is closed at both these points because these 2 points, these are included. So we obtain the solution set in this form. Next is solve this inequality. So it is 2 over mod of x minus 3 is greater than 5. When we were talking about 2 over x minus 3 is greater than 5, we were saying that we do not know the sign of this term. We do not know whether this is positive or negative. So we cannot cross multiply these terms. We cannot cross multiply these terms. But when we are talking about this value, we are saying mod of x minus 3. This is always greater than equal to 0. It cannot be negative. It means if we multiply both sides of this equation with mod of x minus 3, the sign will remain same. So we are saying we obtain that 2 is greater than 5 into mod of x minus 3. This implies us mod of x minus 3 is less than 2 by 5. So this implies us that minus 2 by 5 is less than x minus 3 is less than 2 by 5. And this implies us that 3 minus 2 by 5, we are adding 3 to all the terms of this equation, is less than 2 by 5 plus 3. So this gives us that 13 by 5 is less than x is less than 17 by 5. So the solution set we have is, from this term we can see that these are the values of x. But if we look at the given equation again, if we look at this equation again, we are saying that mod of x plus 3 is greater than equal to 0, but as mod of x minus 3 is in denominator, so this thing is given over here that x belongs to R. But what is the domain of this set? It is x belongs to R minus 3, because x cannot be equal to 3, otherwise the denominator will become 0. So we are saying the solution set we have is this, and the condition we have it is x is not equal to 3. It is coming from this term. So the final answer we obtain it is, if we divide both these values, we get it, this value is 2.6 and this value we get it is 3.4. So we are having the answer as 2.6 comma 3.4. This is the interval minus the element 3. So this is the solution set in this case. This is the solution set in this case. Next is we have to solve this inequation. It is mod of x minus 2 minus 1 divided by mod of x minus 2 minus 2 is less than equal to 0. Now in this case, the denominator part we are having, we do not know the sign of the denominator part, so we cannot cross multiply these terms. So to solve these kind of problems, we are going to talk about that the value of x minus 2, either it can be greater than equal to 0 or x minus 2 can be less than 0. So we are saying, we know that mod of x minus 2, this will be equal to x minus 2 if x minus 2 is greater than equal to 0, and it will be minus of x minus 2 if x minus 2 is less than 0. This is the definition of the mod function, that it is equal to x and minus x if x is greater than equal to 0, if x is less than 0. So in both these cases, this question will become, in first case we are saying when x is less than x minus 2 is greater than equal to 0, this value will become x minus 2 minus 1 divided by x minus 2 minus 2 is less than equal to 0. We get x minus 3 over x minus 4 is less than equal to 0. In the second case, when we are saying x minus 2 is less than 0, this value will become minus of x minus 2 minus 1 is over minus of x minus 2 minus 2, it is less than equal to 0. So these values will give us minus x plus 2 minus 1 over minus x plus 2 minus 2 is less than equal to 0. These two values get cancelled, and on this side we will obtain it is minus x plus 1 over minus x is less than equal to 0. So this implies us that x minus 1 over x is less than equal to 0. So we are having two cases. First is the case when we are saying x minus 2 is greater than equal to 0, this thing we are talking about. So this thing implies us that x is greater than equal to 2, and we are having this inequation. Second, we are saying x is less than 2, and we are having this inequation. Now to solve this first part, we are saying in this case further we have two cases. Either x minus 3 is less than 0, it is less than equal to 0, or x minus 4 is greater than 0. Why greater than 0? Because x cannot be equal to 4. It is in the denominator, x cannot be equal to 4, so it is x minus 4 is greater than 0. So this first part will give us that x is less than equal to 3, and second part will give us x is greater than 4. So there is no common value over here. And the second thing we will have is that x minus 3 is greater than equal to 0 and x is less than 4. It is again less than because x cannot be equal to 4 because this is in the denominator. So this first part we are saying this will give us that x is greater than equal to 3, and second we are saying and x is less than 4. So the solution set we have it is closed interval at 3 and open at 4. Now this interval when we are talking about, this also satisfies the condition that x is greater than equal to 2. So in this case we are having the answer that x belongs to the interval closed interval 3 to open interval 4. Coming to the second part, when we solve this second part, we have two conditions over here. The first condition we are having it is that x is less than 2. We are saying the first condition we have it is x is less than 2, and the equation we are solving over here it is x minus 1 over x is less than equal to 0. So when we solve this equation, when we solve this case, again we are having two cases that x minus 1 is less than 0, is less than equal to 0, x is greater than 0 because x cannot be equal to 0. Second, we will have x minus 1 is greater than equal to 0 and x is less than 0 because x cannot be equal to 0. This gives us x is less than equal to 1, x is greater than 0, x is greater than equal to 1, x is less than 0. In this case, there is no common point over here. In this case, the value we will have it is 0 to 1, open at 0 and closed interval at 1. And it is or in between these two. So the answer we obtain it is 0 to 1. So we are saying that the final answer we will have it is union of both these intervals, union of both the intervals. So the final answer we obtain it is 0 to 1 union 3, 4. So this is the solution set that we have in this case. Next is mod of x plus 3 plus x over x minus 2 is greater than 1. So we are writing it is mod of x plus 3 plus x over x plus 2 minus 1 is greater than 0. This implies as mod of x plus 3 plus x minus 2 divided by x plus 2 is greater than 0. So this implies us these two values gets cancelled. We are left with is mod of x plus 3 minus 2 divided by x plus 2 is greater than 0. So again we will have two cases over here. The first case will be when mod x plus 3 we are saying it is greater than equal to 0. Second, we are saying x plus 3 is less than 0. In this case, the value of this mod will be positive. So the question will become x plus 3 minus 2 over x plus 2 is greater than 0. In this case, this will become minus x minus 3 minus 2 over x plus 2 is greater than 0. So this implies us x plus 1 over x plus 2 is greater than 0, and this implies us that x plus 5 over x plus 2 is less than 0. Why this sign is reversed over here? Because we have taken minus sign common from this term and we have multiplied both sides of the equation with minus 1. Now, further this will have two cases. The first case we will have, it is x plus 1 is greater than 0, x plus 2 is greater than 0, x plus 1 is less than 0, or x and this is and in between these two, x plus 2 is less than 0. Now in this first case we get it is x is greater than minus 1 and x is greater than minus 2. So the answer we obtain is that x is greater than minus 1. In the second case we are having x is less than minus 1 and x is less than minus 2. So the answer we obtain is x is less than minus 2 and it is or in between these two values. And from the given condition we have is x is greater than equal to minus 3. So if we plot all these points, we obtain, we are saying we are having the points over here, this is minus 1, minus 2 and minus 3. What we need is, we are talking about the union of these two, we are saying x is greater than minus 1. X is greater than minus 1 means we are talking about this region. X is less than minus 2. X is less than minus 2 means this region. And this is or, we are saying in between these two it is or, and we are having the condition x is greater than equal to minus 3. So we are saying that x is greater than equal to minus 3. So the common region we have over here, it is this portion we are saying, it is minus 3 to minus 2, this 3 is included, minus 2 is not included, we are saying 3 is included, minus 2 is not included, union minus 1 is not included to infinity, and this is the answer we are saying in this case. In this first case we obtain this answer. In the second case, we obtain the values we will have, it is x plus 5 is less than 0 and x plus 2 is greater than 0, x plus 5 is greater than 0, x plus 2 is less than 0. From the first we are getting x is less than minus 5 and x is greater than minus 2, x is greater than minus 5, x is less than minus 2. So combining both these results, we are saying x is less than minus 5 and x is greater than minus 2. The answer we obtain it is 5. And when we are saying x is greater than minus 5 and x is less than minus 2, the value we are saying it is minus 5 to minus 2 and it is open interval over here. And in this case, from the given condition we have x is less than minus 3. So if we all these points, we are saying x is less than or minus 3. This is the main condition we are talking about. And after this we are having the interval minus 5 to minus 2, it is open interval. So if we plot these points, we are saying this is minus 2, minus 3, minus 5. So the main region we have, it is x is less than minus 3. Then we have the interval minus 5 to minus 2 and all these points, these are excluded. So the common region we obtain, it is minus 5 to minus 3. So in this case, the answer we obtain, the region we obtain, it is minus 5 to minus 3. So by taking the union of both the case 1 and 2, we obtain the final answer in the form, we are talking about the union of these sets. So if we plot these numbers on the number line, we are having it is minus 1, minus 2, minus 3, minus 5. We have to plot the numbers, we have to plot the intervals. It is minus 5 to minus 3, union minus 3 to minus 2, and then union minus 1 to infinity. Now out of these numbers, 5 is not included, 3 is included over here, this point is included over here, 1 is not included. So we get the answer as minus 5 minus 2, because 3 is included, union minus 1 to infinity. So this is the final answer that we obtain. It is minus 5 to minus 2 union minus 1 to infinity. Next we have is to solve this inequality. So if we look at these terms over here, we are saying it is mod of x minus 1 plus mod of x minus 2 is greater than equal to 4. So if we look at these terms over here, it is x minus 1 and x minus 2. So we can see that the critical points we have over here, that from at which these terms will change the value. Suppose I am talking about this is 1, this point it is 2. So if I am considering the values of x on this side means I am talking about the case when x belongs to the interval minus infinity to 1. In that case, the value of mod of x minus 1 and mod of x minus 2, that will be equal to minus of x minus 1 minus of x minus 2. Second case, if I consider that the value of x belongs to the interval 1 to 2, we are talking about this portion 1 to 2. In this case, the value of mod of x minus 1 will be x minus 1 and value of mod of x minus 2 will be minus of x minus 2. And the third case we are considering is when x belongs to the interval 2 to infinity. In that case, both these values will be positive. So we will have mod of x minus 1 is equal to x minus 1. Mod of x minus 2 is equal to x minus 2. So we are saying in this first region, our function will become minus of x minus plus 1 minus of x plus 2 is greater than equal to 4. So we get minus 2x is greater than equal to 1. So this implies us that x is less than equal to 1 by minus 1 by 2. In this second region, when we are saying x belongs to 1 to 2, we have the value, this is positive, so it is x minus 1 minus x plus 2 is greater than equal to 4. These two gets cancelled. We are getting that 1 is greater than equal to 4, so this thing does not hold. So we are saying that there is no value of x between 1 to 2 which satisfies this inequality. There is no value of x in this region. Coming to the third part, we are saying when x belongs to 2 to infinity, this function will become x minus 1 plus x minus 2 is greater than equal to 4. We get 2x is greater than equal to 7. So x is greater than equal to 7 by 2. So what we obtain over here is that when x belongs to minus infinity to 1, we are saying the value of x we are getting it is less than equal to minus 1 by 2. And when x belongs to 2 to infinity, the value of x we are having it is greater than equal to 7 by 2. So the common region we have in both these cases, when we are saying x belongs to minus infinity to 1 and x belongs is less than this, so the answer we are saying it is x belongs to minus infinity to minus 1 by 2 closed interval. It is equality sign over here, and from this portion the answer we will have it is 7 by 2 to infinity and it is closed interval over here. So the final answer we obtain is either x can have this value or we are saying x belongs to this region. So the final answer we obtain it is minus infinity to minus 1 by 2 closed interval union 7 by 2 to infinity. So these are the values shown over here. We are saying in the case when minus infinity is less than x is less than 1, answer we have it is minus infinity to minus 1 by 2. The second case we are considering it is when 1 is less than x less than equal to x is less than 2, we are getting this kind of inequality and we are saying that there is no solution in this region. And the third case we are saying when x belongs to the interval 2 to infinity, x is greater than equal to 2, the answer we are obtaining it is the interval 7 by 2 to infinity. So, the final answer we obtain is the union of these two. The solution set we have, it is minus infinity to minus 1 by 2 union 7 by 2 to infinity. So, this is the final answer, the final solution set that we have in this case.